here's another problem, exercise 14. If tangent t equals -6/5 and t is in quadrant 4, find sine t and cosine t. And again, you may choose method 1 or method 2. And I choose method 1. And I sort of have a special reason for choosing method 1 here. I think method 2 is probably easier, and I think you probably don't need my help with that. So I'm never going to force you to choose a more difficult route. I don't like that approach to life. Take the easy route if you can. So I'm not saying method 1 is easier, but method 1 might lead to a situation people don't know how to deal with. I want to make sure that you see it's not as scary as it might look. Okay, so we're going to take this tangent t equals -6/5, and method 1 I said involves the Pythagorean identity, but this is tangent, so we're going to like what are we going to do with tangent? And so here's what I would do. I'm going to take that tangent expression and write it as sine t over cosine t equals -6/5. I'm turning it into an equation that involves sine and cosine. And because I don't know sine and I don't know cosine, it's kind of like I have two unknowns here, both the sine and the cosine. And you know from algebra that when we have two unknowns, we need two equations. So I'm going to think of this as one equation, but in order to solve for sine and cosine, I need a second equation. So this is where I bring in the Pythagorean identity. And I don't have anything to plug into it yet. I just take that equation. So this is like a system of equations, all right? So it's a system of two equations with two unknown quantities. And once I have two equations and two unknown quantities, I can go ahead and solve. Now, you learn various techniques for solving a system of equations in algebra. One technique that's incredibly useful in math is called substitution. So I will use a substitution technique. So what I'm going to do is I'm going to take this first equation and I'm going to multiply both sides by cosine t, or cosine t over 1 if you want. Cosine t over 1 times -6/5. So I'm multiplying both sides by the same thing. I'm canceling cosine t on the left side. On the right, I get, I can write this as -6 cosine t over 5. So I have isolated sine t in equation 1. The substitution technique is all about isolating one of the unknowns from one of the equations. And then what I'm going to do is I'm going to substitute into the other equation. So I'm going to take, so let me just draw a line here. I'm going to take my equation. So this came from equation 1. Now I'm going to take my equation 2 that I'm going to write as sine t in parentheses squared plus cosine t in parentheses squared equals 1. That Pythagorean identity. And I'm going to use the fact that I isolated sine here to replace sine t with negative 6 cosine t over 5. So that quantity squared plus cosine t squared equals 1 has to be true in this situation. And now I can solve for cosine t. So I only have cosine t involved in this equation, and I can solve it. That's where the substitution technique came into play. So I got some math to do now. I got a square, so I got 36 cosine squared t over 25 plus, now I can use that shorthand notation, cosine squared t. And it helps maybe just to be aware that that coefficient is understood to be 1 there. So I'm going to think of this as 36/25 cosine squared t plus that 1 I'm going to write as a fraction using common denominator here of 25. So I can write as 25/25. And now I can just add the coefficients and combine those like terms. 36 plus 25 is 61/25 cosine squared t. I'm just combining like terms. Let's maybe write those words there. Combine like terms. Okay. And now I think I'm going to continue on a separate sheet of paper for one thing. So I can spread out. Now, to isolate cosine squared, you could either divide both sides by 61/25, or it's a little fancier to multiply both sides by the reciprocal of 61/25. Then I avoid the mess of fractions, right? So I just flip my fraction. I'm multiplying by 25/61 on both sides. 25 and 61 cancels. I have cosine squared t equals 25/61. And now I'm ready to take square roots. Cosine t equals plus or minus the square root of 25/61. I got to choose a plus or minus sign. So you want to get used to this situation where how do you make the choice? We got to go back to the quadrant information. We're in quadrant 4 in this problem. So it's only the quadrant that tells me which sign I have to choose. Now I got to think about it. Quadrant 4, in quadrant 4, x is positive, so cosine is positive. So it's a positive value, and I get 5 over the square root of 61. I'm just going to leave that square root in the denominator okay by me. Okay. Now that's our cosine value. We still need sine. Because the question asked us to find both sine and cosine t. So I can take any relationship with sine earlier on in the problem. I'm going to use this sine t is negative 6 cosine t over 5. Which, of course, I can write as sine t is negative 6/5 cosine t is equivalent. That's kind of convenient because then I can plug in this fraction, right? 5 over the square root of 61 and multiply those fractions. The 5's will cancel. So sine t is negative 6 over the square root of 61. And notice how sine here automatically, it comes out to be negative. That's taken care of, right? We didn't have to fix it. So just notice sine t is negative in quadrant 4. Again, we didn't, it just took care of itself. So again, this was a little bit intense because we used method 1. It's true method 2 would not lead to such a complicated system, but I do think this is good practice for you guys to see this, because it's so common to have to use substitution in a system of equations in math. And so there's the beginning part of the problem. Here's the finish and our final answer. And we're done with exercise 14. I think this is the end of 7.3.